Hey everyone, this is Anthony. I hope you've been enjoying the video so far. In this video, it's sort of going to be a continuation off the previous video that deals with powers or exponents, or depending which term you're more comfortable with. Both are synonymous. Exponents, all right. But in particular, in this video, we're going to be talking about when either the base is equal to 0 or the power is equal to 0, and what that means for us in each different scenario. All right, and so first, let's take a look at an example where the base is equal to 0, and let's say we have squared, 0 squared, 0 to the second power. Remember what this means. This notation means we're going to multiply the base with itself as many times as there is an exponent. So this is the same thing as 0, because that's the base, times itself. So 0 times 0, 0 2 times, because the exponent is 2. So 0 times itself is equal to 0. And you may realize something. You may realize that 0 times anything is equal to 0. So no matter what number this exponent is equal to, we're going to have 0 times itself that many times, which will always equal 0. So when the base is equal to 0, so 0 raised to any power will always have 0. Now, the only case that we need to be a little bit careful of is when the power equals 0 also. So when the base is equal to 0 and the power is equal to 0, that's actually called an indeterminate form. Indeterminate form. So 0 raised to the 0 power. That's a topic for a different video. All right, but just be a little bit careful in this case. But whenever the base is equal to 0, no matter what the power is other than 0, we'll always have 0 as an answer. All right, let's take a look at what happens when the power is equal to 0. All right, and this goes when the base is equal to any number other than 0. All right. So the idea with this, let's say we have 2 to the 0 power. And how do we handle this? Because the rule before with this notation is we're going to multiply the base as many times with itself as there is an exponent. All right. I'm going to show you a different way to think about this. All right. Let's say we have 2 to the 5th, and we divide by 2 to the 5th. All right. For example. Now, you may have been taught in your math class already that when we are dividing, which we are here, there's a fraction, numerator divided by the denominator, and when the bases are the same, the rule is that we subtract the exponents. So this is the same thing as saying 2 raised to the 5 minus 5. We take the base and we subtract the exponents, 5 minus 5. Well, what's 5 minus 5? That's equal to 0. So if you notice, well, where did this 2 to the 0 come from? It came from 2 to the 5 minus 5, which came from a fraction 2 to the 5th divided by 2 to the 5th. Well, 2 to the 5th divided by 2 to the 5th, anything divided by itself is equal to 1. Pretty cool, huh? And now this works with any different scenario that we might have. All right, so let's say we're trying to get 3 to the 0 power. You can come up with any different scenario. It's always going to work because these two numbers have to be the same in order for when we subtract them to get 0 as the exponent. So for instance, let's say we have 3 to the 1st divided by 3 to the 1st. And you might be asking, Anthony, well, why are you picking 3 to the 1st down here? Because when we subtract the exponents, we want the exponents to simplify to equal 0. So if we picked 3 to the 1st, there's nothing else other than 3 to the 1st that this can be down here, because the bases have to be the same in order for us to subtract the exponents. And we need 0 as the exponent for it to match our original problem. So if this is a 1, this is a 1 also. So 3 to the 1 minus 1 equals 3 to the 0. And well, let's go back to here, because, okay, we might not know what 3 to the 0 is. We haven't been taught that yet. But the 3 to the 0 is the same thing as 3 to the first divided by 3 to the first. Anything divided by itself is equal to 1. All right, so any number other than 0 raised to the 0 power will always equal 1, no matter what. All right, so I hope this helps. If there's any questions, leave them in the comments below.